On May 6, 1942, when the fortress island of Corregidor surrendered to Japanese forces, thousands of American M1 Garand rifles fell into enemy hands. Among the captured weapons stockpiled at Manila Bay were rifles still warm from the last American soldiers who had carried them. Japanese naval ordnance officers had been sent to the Philippines specifically to evaluate captured American equipment. These officers were firearms specialists who had examined countless rifles during their careers. Mausers from Germany, Springfields from America, Soviet Mosin Nagants. They understood infantry weapons, or they thought they did. The M1 Garand looked heavy, almost crude compared to the elegant Type 38 Arisaka rifles Japanese soldiers carried, but the weight distribution was unusual. The action moved in unexpected ways. Intelligence reports had described the American rifle as semi-automatic with an 8-round capacity, but reports were just words on paper. The Japanese needed to see it fire. What happened when Japanese engineers first tested these captured rifles would send shockwaves through Naval Command and eventually lead to one of the most desperate engineering projects in Imperial Japan's history. American forces on Bataan and Corregidor had fought with a ferocity that surprised every Japanese officer who faced them. The Japanese 14th Army had expected an easy victory. Instead, they fought for 4 months against defenders who should have collapsed in weeks, and those defenders had been armed with these rifles. The first major engagement where M1 Garands devastated Japanese forces occurred on January 10, 1942, during the Battle for Bataan Peninsula. Japanese infantry launched an assault against American positions defended by the Philippine Scouts. Elite Filipino soldiers serving under American officers and armed with the new M1 rifles. The Japanese had never encountered these weapons in combat before. The attack began with artillery. Then Japanese infantry advanced in waves across open ground using standard assault tactics that had succeeded throughout China. But something went wrong. The volume of fire from the American positions seemed impossible. Japanese company commanders thought they were facing multiple machine guns. The sound was continuous, overwhelming. Men fell before they could close to grenade range. The fire did not come in the expected rhythm of bolt-action rifles. It just kept coming, wave after wave of aimed shots. One Japanese unit lost heavily in just minutes of fighting without reaching the American trenches. After action, reports from Japanese officers described the Americans as equipped with far more automatic weapons than standard doctrine suggested. It was the only explanation that made sense. Except it was wrong. The Philippine Scouts had no extra automatic weapons. They had M1 rifles and soldiers trained to use them. Lieutenant Colonel Philip Fry commanded the 3rd Battalion, 57th Infantry Regiment of Philippine Scouts. After the engagement, he wrote in his report that the firepower of his battalion was beyond his ability to describe. He said it was a slaughter. The Japanese kept attacking in waves and his men just kept shooting them down. That American soldier was doing something Japanese infantry with Arisaka rifles simply could not do. He was maintaining sustained semi-automatic fire at a rate of 40 to 50 rounds per minute. A Japanese soldier with a Type 38 or Type 99 Arisaka, both bolt-action rifles, could fire at most 15 aimed rounds per minute. A skilled rifleman might reach 20, but 40 to 50 was the standard for an American with an M1. The mathematics were brutal. One American with an M1 could put more rounds downrange than 3 Japanese soldiers with Arisakas. A squad of 8 Americans with M1 South matched the firepower of 24 Japanese riflemen. And the Americans did not have to take their eyes off the target to work a bolt between shots. They just aimed and pulled the trigger again and again and again. The Type 30 Arisaka rifle weighed 4.2 kilograms and fired a 6.5 millimeters cartridge from a 5-round internal magazine. It was accurate, reliable, and well-made. Japanese soldiers trained extensively with it. The rifle had served Japan well since 1905. The Type 90, introduced in 1939, was essentially an updated Type 38 chambered for a more powerful 7.7 mm cartridge. At 3.8 kilograms, it was actually lighter than its predecessor. Still bolt action, still 5 rounds, still requiring the soldier to manually cycle the bolt between each shot. Both rifles were excellent weapons for their time. The problem was not the rifles themselves. The problem was that time had moved on and the Americans had moved with it. The M1 Garand represented a revolution in infantry firepower that had been decades in the making. The rifle was designed by John Keynes Garand, a Canadian-born engineer working at Springfield Armory. Garand began development work in the 1920s, testing various semi-automatic designs, while the U.S. military debated whether such weapons were practical for general infantry use. The Army officially adopted the M1 in 1936, making the United States the first nation to field a semi-automatic rifle as its standard infantry weapon. Production began slowly at Springfield Armory in Massachusetts. In 1940, as war spread across Europe and Asia, production accelerated dramatically. By the time Japan attacked Pearl Harbor in December 1941, the United States had produced approximately 100,000 M1 rifles. American war planners understood that equipping millions of soldiers would require unprecedented manufacturing scale. The U.S. government contracted Winchester Repeating Arms Company to produce M1s alongside Springfield Armory. New production lines were established. Worker training programs were implemented. Manufacturing processes were refined and optimized. By mid-1942, when Japanese forces were capturing M1 South in the Philippines, American factories were already producing thousands of rifles per week. The production rate would continue climbing throughout the war. Springfield Armory alone would eventually manufacture over 3.5 million M1 South. Winchester would add another 500,000. The total wartime production exceeded 4 million rifles, an industrial achievement that no other nation could match. But raw production numbers tell only part of the story. The M1 was also designed for mass production in ways that Japanese rifles were not. American engineers had optimized the rifle for manufacture using modern machine tools and assembly line methods. Parts were designed with generous tolerances that allowed for faster machining while maintaining reliability. Components were standardized so that rifles from different factories and different production runs would use interchangeable parts. This was industrial engineering at a scale Japan had never attempted with small arms. By early April 1942, the Japanese 14th Army had captured Bataan. On May 6, Korigata fell. Among the spoils were several thousand M1 Garand rifles in various conditions, tens of thousands of rounds of .306 ammunition, and detailed American field manuals for the weapons. The Imperial Japanese Navy, which maintained its own weapons research division separate from the Army, ordered immediate technical evaluation. Japanese engineers set up a makeshift test range on a former American airfield outside Manila. The facility had been heavily bombed, but enough clear ground remained for live-fire tests. They selected 6 captured M1 rifles in good condition and requisitioned 200 rounds of captured American ammunition. For comparison, they brought Type 99 rifles to measure performance differences. The first thing engineers noted was the weight. The M1, loaded with 8 rounds and carrying sling, weighed approximately 4.8 kilograms. The Type 90 weighed 3.8 kilograms. The American rifle was a full kilogram heavier. Japanese doctrine emphasized that infantry rifles should be as light as possible for soldiers who often fought in difficult terrain. American soldiers were bigger and stronger on average. They could handle heavier weapons. That extra kilogram bought them something valuable. Japanese test fire rears loaded an 8-round on-block clip into the M1. The clip slid into the rifle from the top with a distinctive metallic snap. The bolt rode forward automatically, chambering the first round. They aimed at targets 100 meters away and began firing. The rifle bucked moderately. The recoil was manageable. The action cycled smoothly. The spent casing ejected to the right. The next round chambered automatically. 8 rounds in 7 seconds. All aimed shots. All hitting man-sized targets. Then the empty clip ejected with a sharp ping sound and the action locked open, ready for immediate reload. Reload time was under 3 seconds. 8 more rounds. 7 seconds. The test team included expert marksmen with years of rifle experience. With Type 99 rifles, they could maintain sustained fire of about 15 aimed rounds per minute, 20 if pushed hard. With the M1 Garand, they had just fired 32 rounds in less than 30 seconds. That was a rate of 64 rounds per minute. Even average shooters, after brief familiarization with the unfamiliar weapon, could achieve firing rates that exceeded elite Japanese marksmen with bolt-action Arisakers. By the 5th magazine, completely ordinary riflemen were firing 8 rounds in 8 to 9 seconds, 48 rounds in 1 minute. For comparison, engineers tested the Type 99. They loaded 5 rounds using a stripper clip, took careful aim, fired, worked the bolt, ejected the brass, chambered the next round, aimed, fired, worked the bolt. The rhythm was familiar, practiced, efficient. 5 rounds in 20 seconds, 15 rounds per minute at that pace, which was actually quite good performance. The American rifle lying on the shooting bench had just fired 32 rounds in 30 seconds. Japanese engineers understood firearms engineering. They knew the principles of gas-operated actions, understood how the M1 used expanding propellant gases to cycle the mechanism. But understanding theory was different from experiencing reality. This was not just a mechanical advantage. This was a fundamental shift in what one soldier could do on a battlefield. They thought about the reports from Badon, Japanese commanders describing impossible volumes of fire, describing attacks that should have succeeded but were beaten back by overwhelming firepower. Japanese forces had not been facing overwhelming numbers. They had been facing this rifle. That night, Japanese naval officers wrote their initial assessment reports. The reports were carefully worded, choosing language with precision. Senior naval officers who might not understand the full implications would read these documents. The report started with technical specifications. M1 Garand rifle semi-automatic gas-operated 8-round on-block clip. Weight approximately 4.8 kilograms loaded. Effective range for 100 to 500 meters, rate of fire 40 to 50 aimed rounds per minute in the hands of a trained soldier. Then came the conclusion that would change everything. The report stated that one American soldier armed with an M1 Garand possessed the equivalent firepower of 3 to 4 Japanese soldiers armed with Arisaka rifles. This represented a tactical disadvantage of such magnitude that it threatened the fundamental assumptions of Japanese infantry doctrine. Unless Japan could match or counter this capability, Japanese forces would face increasingly unfavorable casualty ratios in any engagement where American infantry were present. The reports did not state that Japan was doomed or that the war was lost. They just presented facts and let them speak for themselves. The reports reached Tokyo on May 20, 1942. They sat on desks for weeks while officers debated whether to take them seriously. The Imperial Japanese Army mostly ignored the findings. The Army had its own weapons procurement system, its own arsenals, its own procedures. The Army was committed to the Arisaka. The decision to upgrade from Type 38 to Type 99 had taken years. Another change was not going to happen quickly. Besides, Army generals argued Japanese soldiers did not need high rates of fire. They had superior spirit, superior tactics, and the advantage of fighting for the emperor. American firepower was merely mechanical. Spirit would triumph, but the Imperial Japanese Navy paid closer attention. The Navy had always been more technologically progressive than the Army. Naval officers understood that spirit alone did not win battles against superior equipment. The Navy had also suffered significant losses. In June 1942, the Battle of Midway destroyed for Japanese aircraft carriers. The balance of naval power in the Pacific shifted dramatically. Suddenly, the war looked different. Suddenly, the question of how to match American technological advantages became urgent. The Navy established weapons evaluation committees. Captured M1 rifles were brought to Japan for detailed study. Naval officers observed firing demonstrations personally. They watched the rifles being loaded, fired, and reloaded. They saw how quickly the semi-automatic action cycled. They understood immediately. This was not about training or tactics. This was about engineering. The Americans had built a better rifle, and Japan needed to respond, but how? The obvious answer was to build a Japanese semi-automatic rifle, but Japan had been trying to do that for years with limited success. The story of Japan's semi-automatic rifle programs stretched back to the 1930s. Japanese arms designers understood the theoretical advantages of self-loading rifles. They had studied foreign developments, examined captured examples, and attempted their own designs. But each program had encountered the same problems: excessive complexity, high manufacturing costs, and reliability issues. The type of rifle developed in the early 1930s used a gas-operated action similar to the M1 Garand. It functioned reasonably well in testing but required machining precision that Japanese arsenals struggled to maintain at scale. The TIPCO attempted a simpler design but suffered from jamming problems with Japanese ammunition. The Taipatsu incorporated lessons from both predecessors but introduced new complications with its magazine system. None of these experimental rifles performed well enough to justify the enormous cost of retooling factories and retraining soldiers. The Imperial Japanese Army had also recently attempted to copy the American Pedersen rifle in the 1930s. General Yoshida oversaw manufacturing at Tokyo Arsenal for this project. The Pedersen was an advanced semi-automatic design that the U.S. military had tested but never adopted. Japanese engineers obtained examples and attempted to replicate them for Japanese use. The project consumed significant resources over several years but never achieved reliable mass production. By the late 1930s, the Army had essentially abandoned semi-automatic rifle development and committed to the bolt-action Type 99 Arisaka as the standard infantry weapon. The industrial capacity required to mass-produce a working semi-automatic rifle exceeded what Japan could spare from other war production. Japanese arsenals were already operating at maximum capacity, producing Arisaka rifles, machine guns, artillery pieces, and ammunition. Converting production lines to manufacture a completely new rifle design would require months of downtime, massive tooling investments, and worker retraining. And all of this would have to happen while Japan fought wars in China and the Pacific simultaneously. The obstacles were immense. The Navy Committee debated for weeks. Some officers argued for accelerating existing semi-automatic rifle programs. Others argued for improving training to compensate for the firepower gap. Others argued for accepting the disadvantage and focusing resources elsewhere. Then someone suggested a different approach. If Japan could not design a semi-automatic rifle from scratch, could they copy the American design? Naval Command authorized a feasibility study in mid-1942. However, the Imperial Japanese Army had already begun its own reverse engineering project of the M1 Garand shortly after the Philippines campaign. The Army program ran from approximately 1941 through mid-1943, developing various experimental semi-automatic rifles. But the Army ultimately abandoned the effort in 1943 due to manufacturing complexity and resource constraints. When the Army program ended, the Imperial Japanese Navy decided to attempt its own version. The project went to the Yokosuka Naval Arsenal located approximately 45 kilometers south of Tokyo on Tokyo Bay. Yokosuka was one of 4 principal Japanese naval facilities. It had been building warships since the 1860s and housed extensive weapons development laboratories. The project was assigned to the Arsenal's engineering staff in late 1943. The Navy's approach differed from the Army's. Rather than attempting a complete redesign, Navy engineers would focus on a straightforward copy adapted for Japanese ammunition, accepting longer development time in exchange for proven functionality. A small team of engineers and machinists received 3 working M1 Garand rifles, captured American ammunition, and complete sets of American technical manuals. Their instructions were simple. Determine if Japan could produce a copy of the American rifle chambered for Japanese ammunition. The project began in late 1943. The engineering team started by completely disassembling one of the M1 rifles. They cataloged every part, measured every dimension, analyzed every mechanism. The M1 had more than 50 individual components, not counting screws and pins. Some parts were simple stampings. Others required precision machining. The operating rod, the gas cylinder, the bolt assembly. These were complex pieces that required tight tolerances. The team methodically documented how the M1 worked. The rifle used a gas-operated action, meaning that some of the propellant gas from a fired cartridge was diverted through a port in the barrel to push a piston that cycled the action. This gas system had to be precisely engineered. Too much gas pressure and the action would cycle too violently, causing excessive wear and potential breakage. 2. Little gas pressure and the rifle would fail to cycle completely, resulting in jamming. The M1's designers had spent years perfecting these gas system characteristics. Japanese engineers would need to replicate that precision while adapting the system to work with different ammunition that produced different gas pressures. The bolt mechanism presented another challenge. The M1 used a rotating bolt that locked into the receiver through locking lugs. The bolt had to rotate exactly into battery, lock securely during firing, then unlock and extract the spent cartridge case smoothly. The timing of these operations was critical. The extraction had to begin before chamber pressure dropped completely, providing enough residual pressure to help start the extraction process, but not so early that the brass case would rupture. American engineers had optimized these timings through extensive testing. Japanese engineers would need to validate that the same timings worked with Japanese ammunition. The team calculated the machining time for each component. They estimated the tooling requirements. They analyzed the metal alloys. American steel was high quality, carefully heat-treated to achieve specific hardness characteristics in different parts of the rifle. The bolt had to be extremely hard to resist battering from repeated firing. The operating rod needed to be strong, but also somewhat flexible to absorb shock. The receiver required dimensional stability under stress. Could Japanese manufacturers match American metal with wartime material shortages? Japanese steel production was already strained, supporting shipbuilding and aircraft manufacture. Specialty alloys were in short supply. Heat-treating facilities were operating beyond capacity. They estimated the cost per rifle. At peacetime production rates, an M1 cost approximately $50 American to manufacture. That was roughly 150 yen at the exchange rates of the time. A Type 99 Arisaka cost about 70 yen. The American rifle was more than twice as expensive. But cost calculations assumed peacetime industrial conditions in wartime with materials scarce and factories overloaded. The real cost of manufacturing a semi-automatic rifle in Japan would be much higher. Every rifle built meant machine time and materials diverted from other weapons. Production, but cost was not the main problem. The main problem was ammunition. The M1 was designed for 306 Springfield cartridges. The 306 was a rimless bottle-necked cartridge with a case length of 63 and an overall cartridge length of 85 millimeters. The Japanese military used 6.5 millimeters Type 38 cartridges and 7.7 millimeters Type 99 cartridges. Neither was dimensionally compatible with 306. The Type 99 cartridge had a case length of 58 millimeters and an overall cartridge length of 77 millimeters, close but not close enough. To produce a Japanese M1, they would need to modify the design to accept Japanese ammunition. The team started with the simpler option. They tried to rechamber a captured M1 rifle for 7.7 millimeters Type 99 ammunition. Dimensionally, it was close. The 7.7 millimeters Arisaka was similar in size to 3006, slightly shorter case length, slightly different rim diameter, but close enough that the action should work. The team modified one rifle, changed the barrel, adjusted the chamber, filed down the magazine to accept the shorter cartridge. They took it to the test range in early 1944. It fired, the action cycled, but there was a problem. The en-bloc clip system did not work reliably with the Japanese cartridge. The dimensional differences were small, but enough to cause feeding issues. Rounds would jam. The clip would not seat properly. Sometimes it worked, sometimes it did not. Reliability was perhaps 70%. That was unacceptable for a combat rifle. The team tried different approaches. They modified the clip design. They adjusted spring tensions. They changed the feed geometry. Nothing worked consistently. The en-bloc clip was designed specifically for 30-06 dimensions. Japanese ammunition was just different enough to break the system. In early 1944, the engineering team made a critical decision. If the en-bloc clip would not work with Japanese ammunition, they would eliminate it. They would redesign the rifle to use a fixed internal magazine loaded by stripper clips. The Arisaka used stripper clips. The system was proven simple, reliable. A 10-round magazine loaded by 5-round stripper clips would give Japanese soldiers higher capacity than the 8-round M1 while using familiar loading procedures. It would also be easier to manufacture than the complex en-bloc clip system. The decision fundamentally changed the project. They were no longer copying the M1, they were reverse engineering it and modifying the design to work with Japanese manufacturing capabilities and ammunition. This was harder, much harder. The engineers worked through late 1943 and into early 1944. They redesigned the magazine system. They modified the bolt to work with the new feeding mechanism. They adjusted the gas system to ensure reliable operation with Japanese powder pressures. They made detailed engineering drawings. They calculated new tolerances. By March 1944, they had completed a working toolroom prototype. It looked like an M1 Garand, but with visible differences. The magazine extended slightly below the stock. The receiver had a clip guide for loading with stripper clips. The sights were Japanese-styled tangent pattern instead of American aperture sights. They called it the type for rifle after the year on the Japanese calendar. The year 264 in the Japanese imperial calendar was 1944 in the Western calendar. But they did not have a production rifle yet. They had one prototype hand-built in a workshop. Making it work in mass production was an entirely different challenge. Meanwhile, the strategic situation in the Pacific had deteriorated catastrophically for Japan. In August 1942, American Marines had landed on Guadalcanal in the Solomon Islands. This was the first major American offensive operation of the Pacific War. Japanese forces rushed to defend the island, which housed a critical airfield. The battles there became some of the bloodiest fighting of the Pacific War. Japanese soldiers with Arisaka rifles faced American Marines with M1 Garands in jungle combat that neither side had fully prepared for. The casualty reports from Guadalcanal told a stark story. Not just numbers killed, but how they were killed and under what circumstances. Japanese banzai charges that had terrified Chinese soldiers in Manchuria and overwhelmed defenders in Malaya were cut down by semi-automatic rifle fire before attackers could close to bayonet range. American Marines outnumbered and fighting from hastily prepared defensive positions were able to generate such overwhelming volumes of fire that Japanese assault tactics simply could not succeed. The M1 allowed defenders to maintain continuous aimed fire without the vulnerable moments required to work a bolt action. Japanese infiltration tactics, which relied on small units moving stealthily through jungle terrain to get close to enemy positions before opening fire with grenades and close-range weapons, were met with rapid fire that prevented Japanese soldiers from getting close enough to be effective. An American soldier who spotted infiltrators could immediately engage with sustained semi-automatic fire while calling for support. A Japanese soldier with a bolt-action rifle had to choose between working the bolt for a second shot or taking cover. The M1 eliminated that choice. The firepower differential was playing out in jungle combat exactly as predicted. Field reports from American units described engagements where squads armed with M1 South successfully defended against numerically superior Japanese forces. Japanese after-action reports describe the opposite perspective, asterisk attacks that should have succeeded based on numerical advantage failing because American firepower was too intense to overcome. By February 1943, after 6 months of fighting, Guadalcanal was lost. American forces had established air superiority, had reinforced their positions, and had inflicted devastating casualties on Japanese infantry. More importantly, they had established a pattern that would repeat across the Pacific. Japanese commanders filed report after report describing the same problem. Infantry firepower was overwhelming. Japanese tactics developed against Chinese forces armed with bolt-action rifles were proving ineffective against Americans armed with semi-automatics. Some Japanese officers who had fought on Guadalcanal were evacuated and returned to Japan. They were interviewed by intelligence officers. They all told the same story. The Americans had rifles that fired as fast as light machine guns. Japanese soldiers could not advance against that volume of fire. The accounts reached Yokosuka and circulated among naval weapons staff. The reports validated the type for rifle project, but the reports also made clear just how far behind Japan had fallen. While the Navy's engineering team was still hand-building prototypes in early 1944, American factories had been mass-producing M1 rifles for years. The gap was not shrinking, it was growing. Naval Command faced a difficult calculation. Even with the March 1940 for prototype completed, production tooling would take months to prepare. Initial production would be slow, perhaps 50 rifles per month for the first few months while workers learned the procedures. Scaling up to meaningful production would take until late 1944 or early 1945, and that assumed no disruptions. No material shortages, no interference from American bombing. Even if everything went perfectly, Japan might produce 10,000 type for rifles by the end of 1945. The Imperial Japanese Army alone had nearly 2 million men under arms. 10,000 rifles was nothing. It was a drop of water in the ocean. But Naval Command authorized the project to continue anyway because doing nothing was not an option. Because having some semi-automatic rifles was better than having none. Because somewhere in the chain of command, someone needed to try to close the gap. Even if the gap could not be fully closed, the engineering work continued. The team refined the design. They simplified parts where possible to reduce machining time. They adjusted tolerances to make manufacturing easier. They tested different steels to find alloys that would work with wartime material constraints. By spring 1944, the team had built 10 prototypes. All of them worked. Reliability was good, about 95%, which was acceptable for a military rifle. The team began developing production drawings and tooling designs. But Japan's strategic situation was deteriorating. American submarines were decimating Japanese merchant shipping. Raw materials were becoming scarce. Steel allocations were going to shipbuilding and aircraft production. Labor was being drafted into the military or diverted to munitions factories. The type for rifle project kept getting pushed down the priority list through mid-1944. Work proceeded slowly. The Yokosuka arsenal had other projects, ships and submarines and naval guns. The type for rifle was important, but it was not urgent enough to divert resources from higher priorities. Then in November 1943, American forces had attacked Tarawa. The battle lasted 3 days. The Marines landed under heavy fire, fought their way across a coral, atoll barely 3 kilometers long, and killed nearly every Japanese defender. Almost 5,000 Japanese soldiers died on Tarawa. The Marines reported that their M1 Garand rifles performed flawlessly even in the worst possible conditions. Salt water, coral dust, sand, mud, the rifles kept working. The Marines could wade through waist-deep water, climb onto the beach, and immediately open fire with semi-automatic rifles that did not jam. Japanese survivors from Tarawa, the few who were captured rather than killed, told interrogators that the American rifle fire was like nothing they had ever experienced. They described trying to defend prepared positions only to be overwhelmed by the sheer volume of incoming fire. They described watching American Marines shoot their way across open ground where Japanese soldiers would have been pinned down. The tactical advantage was not just about firepower. It was about momentum, the ability to maintain offensive action under fire because you could shoot back while moving, something you could not do with a bolt-action rifle. The Taro reports reached Tokyo in December 1943. They were classified, restricted to senior officers, but they circulated. Word spread. The Americans were not just winning through numbers or superior logistics. They were winning through superior weapons. And Japan had no answer. The engineering team worked through the winter and into early 1944. By March 1944, they were ready to begin limited production. The tooling was complete. The production procedures were documented. The Yokosuka arsenal allocated a small section of the factory to type for rifle production. The facility was located on the third floor of the machine gun plant at Yokosuka, with the project essentially running as a spare time activity alongside the arsenal's primary work, manufacturing 25mm anti-aircraft cannons. The plan was to produce 250 complete rifle sets, not finished rifles but part sets that could be assembled later. This approach saved time because parts could be manufactured when machine capacity was available, then stockpiled until enough components existed to assemble complete rifles. Production started slowly. The first parts came off the machines in March 1944. Quality control was strict. Every component was inspected. Defective parts were rejected and scrapped. By May 1944, about 50 part sets had been completed. Not 50 rifles, but 50 sets of components waiting to be assembled. The assembly process was done by hand. Skilled armorers fitted each rifle individually, adjusting parts to ensure proper function. This was necessary because wartime manufacturing tolerances were not as tight as peacetime standards. Parts that should have been interchangeable sometimes needed minor fitting. The first completed type for rifle came out of the Yokosuka arsenal in June 1944. Test fire rears evaluated it thoroughly. It worked. The rifle was well balanced and responsive. It looked almost identical to an American M1, but the differences were there if you knew where to look. The extended magazine, the clip guide, the Japanese-style sights. The rifle even had the same distinctive ping sound when the magazine was empty and needed reloading, though it happened after 10 rounds instead of 8. By the end of June 1944, 5 Type 4 rifles had been assembled and tested. All of them worked. Naval Arsenal staff wrote status reports for Naval Command. The reports indicated that the rifle was ready for limited field testing and that production could potentially reach 10 to 15 rifles per month if resources remained available. But June 1944 was also when American forces invaded Saipan in the Marana Islands. The battle lasted 3 weeks. More than 30,000 Japanese soldiers died. American forces captured the island and immediately began constructing airfields. Within months, B-29 bombers would be able to reach the Japanese home islands. The strategic situation was collapsing. The Type 4 rifle project became increasingly irrelevant. What good were a few dozen semi-automatic rifles when entire armies were being destroyed through the summer and fall of 1944? Production of Type 4 part sets continued sporadically. When materials were available, when machine time could be spared. When workers were not diverted to more urgent projects, more components were manufactured. By the end of 1944, approximately 100 part sets had been completed. About 100 rifles had been fully assembled. Most sat in storage at Yokosuka. A few were sent to military schools for testing and evaluation. There is no confirmed record of any Type 4 rifle being used in combat. The war was moving too fast and there were too few of them to matter. As American forces island hopped closer to Japan through 1944 and into 1945, Japanese commanders saw the M1 Garand again and again. On Peleliu in September 1944, American Marines and Army units faced some of the most sophisticated Japanese defensive positions of the war. Japanese forces had abandoned banzai charges in favor of defense in depth using caves and fortified positions. But even from prepared defensive positions, Japanese soldiers found themselves outmatched in firefights. American infantry could suppress Japanese firing positions with rapid semi-automatic fire while other units maneuvered. Japanese defenders with bolt-action rifles struggled to maintain the rate of fire necessary to stop American advances. On Iwo in February and March 1945, the firepower advantage became even more apparent. The island was a volcanic rock with limited vegetation and nowhere to hide. Japanese forces had spent months preparing elaborate tunnel systems and fortified positions. They had machine guns, artillery, and every defensive advantage except one. In close-range firefights, when positions were overrun, American Marines with M1 South could generate overwhelming firepower. Japanese soldiers emerging from tunnels to counterattack were cut down by semi-automatic fire before they could close to grenade range. American troops assaulting bunkers could maintain suppressive fire with their rifles while grenades were prepared and thrown on Okinawa from April through June 1945. The pattern repeated on an even larger scale. This was the largest amphibious assault of the Pacific War. Over 100,000 Japanese defenders faced nearly 200,000 American attackers. The battle lasted 82 days and became one of the bloodiest engagements of World War II. Japanese forces fought with desperate courage, knowing that defeat meant American forces would be positioned to invade the home islands. But courage could not overcome the fundamental arithmetic of firepower. American infantry units could generate 2 to 3 times the rifle fire of equivalent Japanese units. In prolonged firefights, this advantage was decisive. Every battle reinforced the same lesson. American infantry with M1 Garands could generate firepower that overwhelmed Japanese defensive positions. A Japanese soldier with an Arisaka could fire 15 aimed rounds per minute. An American with an M1 could fire 40 to 50. The mathematics had not changed since that first engagement on Badon in January 1942, and Japan still had no solution. By early 1945, American B-29s were bombing Japanese cities regularly. Industrial production was collapsing. Steel was unavailable. Coal was scarce. Electric power was unreliable. The Yokosuka arsenal was damaged in multiple air raids. Production of type for rifles stopped completely. Before the war ended in August 1945, the final count was approximately 250 parts sets manufactured, with about 125 rifles fully assembled when Japan surrendered in August 1945. American occupation forces entered the Yokosuka arsenal and found approximately 20 complete type for rifles in storage. Another 50 rifles were discovered at the Kratewashino factory. An American technical team examined the rifles. They recognized the design immediately. It was clearly based on the M1 Garand. They were surprised by the quality of the workmanship. The rifles were well made, carefully assembled, mechanically sound. If Japan had started this project in 1940 instead of late 1943, if they had committed the resources needed for mass production, the type for might have mattered. But starting in late 1943 meant the rifles arrived too late and in numbers too small to affect anything. The American technical team wrote a detailed report about the type for rifle. The report noted that the Japanese had successfully reverse-engineered the M1 Garand despite significant manufacturing challenges. They had adapted the design to work with Japanese ammunition, had solved the feeding problems that the en-bloc clip presented, and had created a functional semi-automatic rifle. The engineering work was impressive. The rifles were well made. Japanese machinists had successfully replicated complex American manufacturing processes using different tools and materials. But the report also noted that Japan had only produced about 125 rifles from late 1943 through August 1945. In that same period, American factories had produced over 4,000,001 rifles. The comparison was devastating. It illustrated perfectly why Japan lost the war. Not because Japanese engineers were less skilled. The Type for rifles proved Japanese engineers could match American design quality when given sufficient time and resources. Not because Japanese soldiers fought less bravely. Every battle of the Pacific War demonstrated Japanese willingness to fight to the death, but because American industrial capacity was simply overwhelming. The United States in 1944 was producing more war materials than the rest of the world combined. American factories were manufacturing aircraft at a rate of over 90,000 per year. American shipyards were launching one new merchant vessel every single day. American steel production exceeded 90 million tons annually. American automobile factories had converted to tank and truck production, churning out thousands of vehicles every month. Japan, by contrast, was struggling to maintain even basic industrial output. By 1944, American submarines had effectively severed Japan's maritime supply lines. Raw materials were scarce. The machine tools needed for precision manufacturing were wearing out and could not be replaced. Skilled workers were being drafted into military service or killed in air raids. Electrical power was unreliable due to bombing damage. Factories were being destroyed faster than they could be rebuilt. In this environment, asking Japanese industry to mass-produce a complex semi-automatic rifle was simply impossible. The resources did not exist. The industrial capacity was not there. Even if every single problem with the Type for rifle had been solved in 1942 instead of 1944. Even if production had started 2 years earlier, Japan still could not have matched American production. The gap was too wide. The industrial foundations were too different. The Type for rifles captured by American forces were shipped to the United States for study. About 20 of them ended up in American collections and museums. The rest were likely destroyed. Today, a Type for rifle is an extremely rare collector's item. Only a few dozen are known to exist. They represent one of the most interesting might-have-beens of World War II. What if Japan had recognized the advantage of semi-automatic rifles earlier? What if they had committed the industrial resources to mass production? What if Japanese infantry had faced American Marines on Guadalcanal and Tarawa armed with rifles that matched the M1's firepower? The answer is probably that it would not have mattered much because the rifle was just one piece of a much larger puzzle. American advantages in industrial capacity, logistics, air power, and naval strength were so overwhelming by 1943 that no single weapon system could have changed the outcome. But it is still worth asking the question because the story of the Type for rifle is really a story about how wars are fought with more than just courage and tactics. They are fought with engineering and manufacturing and industrial capacity. Japan's soldiers were brave. Japan's engineers were skilled. But Japan's factories could not match American production. And in the end, that made all the difference. The irony is that Japanese naval intelligence saw the problem. Clearly in May 1942, technical reports from the Philippines told them exactly what they were up against. The M1 Garand gave American soldiers a 3-to-1 firepower advantage. That advantage would translate into higher casualty ratios in every infantry engagement. The mathematics were inescapable. But knowing about a problem and solving it are two different things. Japan tried to solve it. They reverse-engineered the American rifle. They adapted it to their ammunition. They proved they could build it. But proving you can build 100 rifles in a factory is very different from building over 4,000,000 rifles in factories across the country while fighting a global war. That is the lesson of the Type for rifle. Not that Japan failed to try, but that trying was never going to be enough. Because by the time Japanese engineers began their project in late 1943, American factories had already produced over 2,000,001 rifles, and American production was accelerating while Japanese production was reaching its limits. The gap could not be closed. It could only grow wider. And that is exactly what happened. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. And we would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories